To find a reference angle, we're going to find the acute angle that our angle makes with the x-axis. It's always with the x-axis and never with the y-axis. Because it's acute, it needs to be less than 90 and it needs to be positive. So there's some formulas you can use that we talked about in class, but I like to use some simple geometry instead. So let's go ahead and sketch a 145-degree angle. So it would look something like this. So the reference angle is going to be the acute angle that's formed between this and the x-axis, never the y-axis. So the acute angle I'm looking at is the angle right here. Well, like I said, using some simple geometry and the fact that I know that this is 180 degrees, all I have to do is figure out, well, if I've gone 145 to get here, how much further do I need to go to get to 180 degrees? And doing some simple subtraction, that tells me I've got 35 degrees farther to go, so 35 degrees is going to be my reference angle. Okay, it's that simple, no formulas required. Next up, I have 280 degrees. So again, let's sketch that angle. And let's see, I know that down here would be 270, so I've got to go a little bit past that. So 280 degrees is going to be somewhere there in quadrant 4. Again, I want to find the acute angle that's formed between the angle we drew and the x-axis. So what a lot of people do in this case is they know that this is 270 degrees, and so what they want to tell me the reference angle is they find that angle right there and tell me it's 10. And 10 degrees is not the reference angle this time. 10 degrees is formed with the y-axis, and our reference angles are never found with the y-axis. They're always found with the x-axis, so that's what I want to find. Since I know, though, that this was 10, I guess it could be somewhat useful. Using some simple geometry, since I know that's 10, then this must be 80 degrees, because it needs to make up the quadrant of 90. Some other ways to think about this, I know a full circle is 360. I haven't gone quite a full circle. I've only gone 280. So I could subtract and also find 80 that way. So again, there's some simple geometry that we can use to find these reference angles. All right. Last up, we've got negative 130 degrees. Remember, a reference angle will always be positive. The negative angle tells me to rotate clockwise. So rotating 130 degrees that's in the negative direction would end me up somewhere over there in quadrant number 3. Again, a reference angle is always found between the x-axis and never the y-axis. There's some formulas we can use or use some basic geometry. Knowing I've gone 130 degrees, and I'm just going to ignore the negative at this point, I know once again that to get to 180, I've got to go 50 degrees farther. So my reference angle is going to be 50 degrees, a positive acute angle. Not negative 50, just 50 degrees for that reference angle. All right? Doing these in radians down here, these are even easier as long as you recognize a simple trick. As long as my denominator is one of the special denominators, remember there's 3 special ones. There was 4, which was pi over 4 or 45 degrees. There was pi over 3, so 3 is another special denominator, that's 60 degrees. And then there was pi over 6, which was 30 degrees. As long as my denominator is one of those 3, this trick will work. It won't work if it's not one of those, so we'd have to try something else. Although the ones you see this year will be one of these denominators. So I recognize 7 pi over 4 as a special denominator, so here's how it works, very simple. Your reference angle is pi over 4. Just scribble out anything else, okay? This trick only works if your denominator is one of the special denominators. So pi over 4 is my reference angle. For negative 4 pi over 3, once again, I recognize that 3 is a special denominator. So my reference angle is just pi over 3. Scribble out all the rest. Pi over 3, also known as 60 degrees. So I know that, yep, that is a positive acute angle.